Hi, let's review when to use each one of the formulas that we have in table T. Alright, so that's the first thing. You don't need to actually memorize any of these formulas because you're going to find them in table T. So have that right in front of you, have a calculator, and let's get this done. First problem, how much heat is absorbed when 42 grams of water as the temperature changes from 73 to 88? What has happened to the water? I see in the description that the temperature has changed. There's only one formula that allows me to actually place a change in temperature, and it's right here, the first one. So that is the one I'm going to place right here. And let's see what values we have to plug in. Q is the amount of heat, so I'm going to solve for Q. M is a mass, in this case is 42 grams. C is a constant, I'm going to find that in table B, okay? If you look that up right now, it's right in front of the reference table. And you're going to find that it's 4.18. That's the specific heat capacity of water. Then we have delta T, the triangle T, and that is really calling you for temperature, but only for a temperature change. So you're not going to use 73 and you're not going to use 88. You're going to use the difference between them. So if you take 88 and subtract 73, you're going to find that the temperature actually got raised by 15 degrees. So then that's the number you're going to use. Now, when you've done that, when you've placed the numbers where they belong, now is when you grab the calculator and you can pause the video now to see if you are going to get the same answer as I'm getting. So I'm plugging it in. And yes, I got that. It's 2,633.4 joules to actually change the temperature of water by that much if it's 42 grams of water. Now, if we have a problem that is asking us to change a phase, like melting, freezing, condensing, and evaporating, the temperature doesn't really change. So then we have examples like this one. How many joules of energy are required to melt? And this is what's happening to the water right there. 23 grams of water at 0 degrees Celsius. Now, again, there's no change in temperature in phase changes, if you remember the graph. So then I cannot use the first formula. I would actually select between this one and this one. Now, I am going to remember that heat of fusion is really the heat needed to actually melt a gram of water. So then that means that I'm going to use Q equals MHF. I could use this formula for something that is melting, solid to liquid, or also a sample of water that may be freezing. So either way, solid to liquid or liquid to solid, this is the formula that I'm using. Okay? Keep that in mind in case you see a problem that is going in reverse. All right, the mass of water in this case is 23. And the heat of fusion, oof, what's that? Okay, that's another constant. Turn around to table B, and you'll find the heat of fusion for water happens to be 334 joules per gram. And now I grab my calculator, pause the video, calculate it, and I get 7,682 joules of energy to melt that sample of water. Third problem. How much heat is released when 36 grams of water are condensed at 100 degrees Celsius? Okay, so condensation is really the opposite of evaporation. So if I'm going to evaporate, it's going to go from liquid to gas. But condensation is exactly the opposite, gas to liquid. Okay, so then that means I need the formula that allows me to put heat of vaporization. So I'm using the third one now. Q equals mHV. I'm calculating Q. My mass now is 36. Heat of vaporization, again in table B, you're going to find that it is 2,260. And grab your calculator. 36 times 2,260. It's going to be a much higher number. 81,360 joules. I want to make you aware that in these problems of changes in phase, you don't end up using the temperature at which this is happening. 100 degrees Celsius is the the boiling point of water. The boiling point of water, 0 degrees over here, is the melting point of water. Neither of those temperatures actually have anything to do with the formula. So you don't plug in a 0 and you don't plug in 100 in any of them. So you leave them right there where they are. That's just information that is given to you, but you're not going to use it as a number in the formula. Okay, hope that helped out clear any problems you had using these formulas. I will see you in class.